Okay, reference angles. Reference angles are very important in trigonometry because it helps us just kind of solve these simple trigonometric equations that we're doing in activity 20-1 and 20-2. So let's just talk a minute about reference angles. Well, reference angles, which I have right here, your reference angles, I'm going to denote by phi because we use theta and x already for unknown angles. So I'm going to use phi for my reference angles. Now, what's important to know is my phi will always be positive, and they're an acute angle, meaning that it's going to be between 0 and 90 degrees or 0 and 2 pi. Now, right below here, I give you some general ways that you can actually find the reference angle, but after you do it for a little bit, it'll become second nature. So let's take an example. If we take arc sine of an angle right here. Well, you're going to get a positive answer because when we think about the range of answers in which we get for arc sine, arc cosine, and arc tangent, we simply use CAST, C-A-S-T, and this tells us which quadrants where we're actually going to get our answers at. Well, sine, you're going to get an answer between negative pi over 2 and pi over 2 for arc sine. So that means we're going to get an answer in quadrant 1. Quadrant 1 conveniently is going to be a nice positive angle, and our quadrant N is going to be an acute angle because quadrant 1 is between 0 and 90 degrees. So really, sine, we don't have to worry about. Anything in quadrant 1, whatever angle you get, if you're doing arc sine, arc cosine, or arc tangent, those are going to be your reference angles. Quadrant 2 is going to be a little different. And this is going to happen with cosine. When you have cosine, cosine is the only one in quadrant 2. When you take arc cosine and your angle is greater than 90 degrees or greater than pi over 2, you're going to have to take pi or 180 degrees and subtract from the angle that you actually get. I'll work an example here in a second. And in quadrant 4, well, quadrant 4, you can see here, I just simply say take the absolute value of arc sine and arc tangent, because you see arc sine and arc tangent here is in quadrant 4, but it's going to be between negative pi over 2 and 0. Now, arc tangent will not be negative pi over 2 because it's not included, but all your negative answers are going to be down here in quadrant 4. You take the absolute value of it, and you'll be good. So let's look at an example of each one of these. Let's take, for example, say we do arc sine. So we do arc sine of, I don't know, let's just pick one here. Say arc sine of, let's just keep it easy, square root of 2 over 2. Well, arc sine of square root of 2 over 2, you can look on your unit circle. It's going to be the y value. That's square root of 2 over 2, which is going to be at pi over 4 or 45 degrees. Well, pi over 4 is between 0 and pi over 2, and is positive, so you would actually use pi over 4 as your reference angle. And of course, this is in quadrant 1, simply because arc sine is positive in quadrant 1. In quadrant 2, let's do an example of cosine. Say we get something that is arc cosine of, say, negative square root of 2 over 2. Well, the domain, your range of answers for cosine, it's going to be in quadrant 1 and quadrant 2, but because my x value is negative, it's going to be quadrant 2. So that's going to give me an answer when we look in quadrant 2 to see what point is square root of 2 over 2. Negative square root of 2 over 2. That's going to be 3 pi over 4. Well, here 3 pi over 4 we cannot use as a reference angle because it is not an acute angle. So we need to find our reference angle. In this case, we would just simply take pi minus 3 pi over 4. Rewrite pi as pi over 1. Multiply your bottoms because now we're adding and subtracting fractions. That'll be your new bottom. That's 4. Multiply up from back to front. 4 times pi is 4 pi minus, bring your operator over, 1 times 3 pi gives me 3 pi. And then we just simply do the math on top. 4 pi minus 3 pi. Well, really the pi stays. So we do the math of the numbers in front. 4 minus 3 is nothing more than 1, so we don't need to write it, and your bottom stays. So my reference angle would actually be pi over 4. All right, let's look at a quadrant 4 example. Let's just say in quadrant 4, we do let's say arctangent of -1. Well, arctangent at -1, if you put it in the calculator, it's going to give you negative pi over 4 or negative 45 degrees. Well, at this point, we can't use negative pi over 4 and negative 45 degrees. Even though it's still an acute angle, it's negative and we want the positive. So we just simply take the absolute value of negative pi over 4, which is just pi over 4, which is what your reference angle will be. Now, each one of these is distinctly different angles, different answers, but yet we still have the same reference angle of pi over 4, because the reference angle we use to find, you'll see in the next video, we'll use to find actual solutions to simple trigonometric equations.